So we'll get started. And I'm going to do some basic drawing here so that you guys can follow along. I'm going to the top and going to create 2D and sketching an arc right at the center here. Let's just go with the basic shapes that we've got in the software program. So I've just got a diameter of 4 inches, and I'm going to click OK, so it places down right at the center of my screen there. And when I move my cursor around, you can see the preview for the next circle is in orange if I want to click, or if I want to type in the center point of my next circle location, I can type that in on the left-hand side here. I'm going to cancel out of the arc function, and I'm going to sketch a gear shape that we can follow along for Wire EDM. And I'm going to go to create 2D, and I'm going to the drop down here for gear, and I'm clicking on gear. And again, we're just going to start with our basic shapes here for the circle and for the gear, for the number of teeth, and everything else in here we're going to leave as default. 16 number of teeth, pitch diameter of 3.750, outside diameter of 4.250, things like that. The only thing I'm going to change is the location of it. So the origin right here in X, let's see. Let's move it. Let's move it 12 inches out. And then click OK. So I've got my circle and I've got my gear. I'm going to make a circle on the outside perimeter of my gear as well. So I'm going to go to arc. I'm going to type in the center point of 12 inches. So I'm going to move that circle out 12 inches there. And I'm going to make the diameter. Let's make it double. Let's go 8 inches for the diameter, and I'll click OK. So basically, I'm just going to sort of create this sort of wrench shape here. There's going to be a hole here, and there's going to be a hole in the center for this gear to follow along the spline. And so I'm going to create a line, and I'm really not connecting the two circles here. I'm just sketching. I'm going to sketch at about X1, Y0, somewhere around here. And this is sort of a good point. As I'm trying to sketch, you can see all of these construction lines moving around. Now, if I want to turn off these reference locations, I can go down to the bottom here with these icons. And I am in the way of where you can see here, so I'll move myself. Okay, so down in the bottom right corner now, you can see these different icons, and you can see this magnet icon. I'm going to leave that turned off. I'm going to leave that turned on. That's my snap increment. So every 1/16 of an inch, when I'm sketching, it's going to move over a 1/16 of an inch there and snap right to that location. But I'm going to turn off the flyouts, which is right next to it, and I'm going to turn off the XY tracking. So now when I'm sketching, I'm not having those geometry construction lines and XY tracking reference points. So now I can go exactly to X1, Y0 and click right there as my start point. And I'm going to move it out. This is about 10 inches out. Actually 9. So you can see the start point is X0, Y1, and the end point in absolute coordinates is X9, Y1. And I'm going to do that down at the bottom, X0, Y -1, and then move it out X9, Y -1. And then I click cancel. I want a hole in here as well. So I'm going to go to arc, and I'm going to make a 2-inch diameter inside to make a hole like this, and click OK. So this is the shape that I have so far, and I'm going to trim away the extra amounts of the lines over here. You can see my cursor, and then trim the extra amounts of the line right here as well. By going to the top, I'm going to Utilities. I'm going to quick trim right here. And then I'm just going to trim away these two lines on the right-hand side, these two lines on the left-hand side that are extra, and I'm going to delete the extra amount of the arc right here on the left, and these extra arcs over here on the right. So now we have sort of this wrench shape with this spline shape that I want to cut out specifically. For whatever reason, if I need to fixture this piece of stock in the Wire EDM machine where this hole is going to be your reference for X0, Y0, I'm leaving it here just to show you that we can leave this as a reference location. The wire can move to this center location of this spline, thread the wire, and then we're cutting the inside profile of this shape here. So that's what we're doing today in 2-axis. And then we'll get into the CAD for 4-axis to follow along with that. But we're just sticking with 2-axis to start with. I'm going to save this as webinar, as a BobCAD file. I'm just going to name it webinar. And I'm going to check the comments, see if you guys have any questions so far. Nope, nothing so far. Let me know if you guys have any questions with what we've gone over. We've just basically sketched a 2-inch diameter circle and a 4-inch diameter circle from the center. Sketched a gear shape 12 inches out. A diameter here, the OD of 8 inches. That same 12-inch location here. And then connected the two with a line going across like this, 1 inch above and 1 inch below. So 2-inch thickness here. All right, perfect. So enough with the CAD. We'll get into Wire EDM, where I begin by going to the top and going to CAM and starting a new job. We select Wire EDM and we select what machine we are using so that it will format the G-code specific to that machine. And I'm going to scroll up and select Fanuc. We'll go with Fanuc 4-axis. It'll output in the 2-axis G-code here with this example. And then when we get into 4-axis, it'll also output the 4-axis G-code. And we do have the ability to output in IJ and K values, or the ability to output in X, Y, and UV coordinates for 4-axis. We'll get into that later. But first, we select our machine as Fanuc 4-axis, and then I click on Stock Wizard. All right. And then it asks for our workpiece. I don't have a 3D model of this. We could maybe model it out and view it in simulation and make sure everything is cut to size correctly in simulation. That's what this is used for. I would click on the solid model here and go to next, but I don't have the solid, so I'm just going to click next here, this next arrow button, which brings us into our stock wizard. So it starts with this rectangular shape, and I'm looking at it on an angle now by clicking and holding the scroll wheel and moving my mouse to see it on an angle here. Now I want this as my starting shape. So instead of rectangular, I'm going to move over to the different icons at the top here for my stock definition, for my stock types. We also have rectangular. If I click calculate stock, you'll see it come up as a from rectangular to cylindrical. Now it's a cylindrical shape. And then I tab over from cylinder to wireframe. And I'm going to go with wireframe because I'm just going to hold shift and click on the outside profile here so that it chain selects my outside profile that I want as my original stock. And then I click calculate stock over on the left-hand side to calculate that. And I'm just going to leave it as the default thickness here of 1 inch, and top of stock would be starting the extrusion from Z0 down a height or thickness of 1 inch, 1 inch height here. And you know what? After the fact, I also want to include this hole as my original, maybe I've already drilled this out or I've already cut this hole out in the center. So I'm going to select in my geometry. I'm going to select that circle as well and hit calculate stock again to remove that hole for us. So I can see that in simulation. Not super necessary, but nice to be able to see, okay, I'm starting at the center point of this hole for my reference point at the machine. It's going to move over 12 inches and then cut out the inside profile in 2 axes. And after that, we go to our next page. So you can see the next arrow button down at the bottom left here. Click on that, and that brings us to our machine setup location. So if our reference point at the machine, x0, y0, is right here at the center of the hole, we don't have to move it at all because it's already referenced with our CAD origin location. If I needed to move it to here or maybe at the end of the part here, I can highlight this box origin over on the left-hand side in the machine setup page. And I can click on this point, and that would be the new x0, y0 in the G code for us. So it would use that as a reference at the end. I'm not going to use that. Again, I'm going to use the center point of the hole so I can highlight origin again, highlight the circle, and select the center point right here of the circle. So we're at x0, y0, z0 in the CAD coordinates here, and it lines up with our CAM coordinates, the G code coordinates that we're going to be outputting. And then I'm going to scroll down to the bottom and click OK. And so that's my G54 location right there. And then we're going to be cutting out this shape here. Oh, now maybe, now obviously there's no location yet for the thread to be, for the wire EDM to thread through in the stock over here. So maybe let's make a hole in here for our stock to see that in simulation as well, and make it a little more realistic. So let's say we drilled a 1/2-inch hole through the center of this spline shape. I'm going to go to a top view again by clicking on this top view icon right here. And I'm going to sketch a 1/2-inch circle in the center of this spline by going to the top, going to create 2D, and going to arc again. And then diameter of a 1/2 inch. And the center point is x12, y0, z0. And I'm going to click OK. So now after the fact, I can modify my stock shape by going to the CAM tree again. So you can see I'm moving back and forth from CAD back over to CAM. I can move back over to CAD, manipulate the drawing here, go back over to CAM, change the stock, change the toolpath, things like that. So I'm back here in the CAM tree, right-click on stock, and go to the stock wizard. And then I'm going to click on the circle here and click calculate stock so that it cuts through that shape for my stock as well. And then I'm going to click OK. So you can see that I can modify the stock at any time in the CAM tree to be able to see in simulation. I can also right-click on stock in the CAM tree. There's a couple other options under stock wizard. Maybe I don't like this really light blue color for my stock. I can change the color right here to a different color. I can also right-click on stock and change the transparency. So maybe the stock is a little bright for my taste. I can right-click and go to transparency and make it a higher transparency so it's more see-through. I like it more like this so that I can see it better. If I've got a solid model behind it, I can easily see the difference between the stock and the solid model that I'm ending up with, my workpiece. So from there, I'm going to get through creating the toolpath for the spline. I'm going to go back to a top view, and I'm going to go over to the CAM tree, and I'm going to right-click on Machine Setup 1 in the CAM tree down at the bottom here. And then you can see our 3 options for 2-axis cutting. 2-axis inside for an inside shape, 2-axis outside for an outside profile cut, and 2-axis open if it's an open shape. Maybe I'm only doing half of the spline, I can do half of it with this option, as an example. And then the next 3 options down are the 4-axis cuts, 4-axis inside, outside, and open. So I'm going to select 2-axis inside, because this is going to be an inside profile for my spline. I'm going to select geometry. So I'm going to click that Select Geometry button, and I'm going to hold Shift and click on one of the edges of the spline here. Hold Shift and click to chain select the whole thing. If you don't get your chain selection, or if you have a selection missing, like that edge might have been missing there, you want to look at the picking manager, which I'm covering up here. So up at the top right corner, now you can see the picking manager. I usually have it turned off, but the auto connection option is if you wanted to just click on something, it'll chain select something for you. It could be useful for chain selecting wireframe and surface edges of a solid model, things like that. But I usually have it turned off so that I can chain select when I want to, and I can individually select geometry, certain lines and things like that. So again, I have it turned off for the moment. Then I hold Shift and click to chain select the whole spline. And then I scroll down to the bottom and click OK. Brings us back to the Wire 2-axis wizard page here. Since I've selected my geometry, I can go to the next page. We have our upper guide and lower guide. Doesn't change anything in the G-code necessarily, but we can see the simulation and make sure it looks very realistic. We can change the taper from none. So if there is a constant taper angle, we can type in the number here. And if there's a land and taper, we can type in the land height and the taper angle here. I'm going to leave that at none. I'm going to go to the bottom left corner here where there's this use glue stop with leads drop down. So if I click on it, you can see an example of what that looks like. So it will create a lead in, go around, create a lead out, and leave a little tab there that we could cut out later if we don't want the slug to fall out of the shape there. So I'm going to turn this off for now. Drop this down and click no glue stop or no tab, and then click next. And then it leaves us with a rough cut and a skim cut option. If I'm just doing one cut, I can delete one of these out here by highlighting it and hitting the red X over here at the bottom left. Then we go to our next page. And these are normally set by default, but you can change your cutting conditions and things like that here, power setting and feed rate for all of the cuts after this page. Next page, we can set the tolerance levels and our work offset number. Number 1 would be our G54 location there. 2 would be G55, 56, and so on. Then our next page, if we're cutting multiple shapes out, we can set the closest sorting order to give us the fastest cut time. No sorting. So from the first page when I selected my geometry, the way I selected my geometry would reflect the sorting order here. So let's say you've got number 1, if you see my cursor here, number 1 and then number 2. And then let's say number 3 across. Between those two, there's a clamp in the middle that I need to avoid. I could go 1, 2, and then 3, and then go around based on how I selected my geometry, or sort it in an X or a Y direction. We'll go to closest and go to our next page. We have coreless cutting. So we can start from the center and do multiple passes, set a step over. We'll do a standard profile cut. We're just going to do one rough cut and then do a second cut for the skim pass. We can turn on machine compensation. We can go around the corners. I don't really see this I don't see this being used a whole lot in Wire EDM, but if you need it to be used, you can break up the corners here, like on the outside. You can go around with a loop radius, different options like that, or a smoother transition around the corners there than just, cutting a 90-degree angle, sharp corner cut around. Internal corners, if you want to cut into the corners here on the inside, you can select one of these shapes as well. Next page, we get into our lead in and lead out. So we have down at the bottom, lead in and lead out. We have parallel, and you can set the length of it. We have a perpendicular lead in and lead out option. We have perpendicular blend, so more of like a tangent arc around for your lead in and lead out, and circular, which is also a tangent cut. I'm going to go down to the bottom where we have select point and point blend. Now, point blend would be if I select a starting point, it'll start at that point and then go tangent into the cut. I'm going to do more of like a right angle lead in, lead out with select point. And then I'm going to go to the bottom and click this button, pick points. And then I'm going to highlight the circle for my start hole and then click on the center point right there and click OK. And that gives me a location of X12, Y0. So if you haven't created that in your drawing yet, you can always just type in the number for your start point here for your lead in and your lead out. And then you can hit next. So what it's going to do is it's going to go to that location, X12, Y0, thread the wire, and then start there and cut into the shape from there. Then we have our offset for the wire. I'm going to set that to 1 thou. Power settings to control for your machine, and feed rate. So I'm going to type in 10 inches per minute. And you can set the speed and tension of the wire here. So all of those can be output in the G code depending on how your post processor is set up. You can take a look at how it's going to output in the G code once we post it. Then our next page, we are going to set the number of skim passes. If we're going to set the skim pass to go in the same direction as the rough cut, or reverse skim passes. So if we're doing multiple skim passes, go back and forth. And then set our compensation at the bottom. Next page, the corner type options as before, lead in and lead out type options as before. I'm going to just go with the same lead in and lead out as before. We probably wouldn't have to start at the same location for the skim pass because the slug has already dropped out of it. But to make things easy for us, lead in, we'll go to select point, and then I'll pick that point here of the start hole and click OK. Now, in the skim pass here, before I hit next, in the skim pass also, down at the bottom, we have an overlap amount. So if we didn't want to start, or if we didn't want to end right where we started along the profile, we could go a little bit further past the start point so that, maybe there's not like a notch right there where we start and end. It'll go a little bit further past with that overlap amount. Next page, we have our offset and feed rate. So I'm going to set 1 thou for the offset, and I'm going to set a feed rate of 10 inches per minute. Now, if these numbers aren't output in the G code, if those are all being controlled at the machine, you don't necessarily have to type them in here. But I do like typing in a feed rate because that way I can go into my simulation and it can show me an estimated cycle time at least for these options here. And then I'm going to go down to the bottom and hit compute, and I'll see the toolpath. So it's sort of on an angle, right? It starts at the start point, but then it starts like down into the tooth of the gear here. I want it to go perpendicular like this, maybe down into the gear to start with like that. So I'm going to right click on the feature here in the cam tree. And I'm going to go to edit. And then on my leads page for the rough cut and the skim cut, I'll check this box perpendicular to closest. So it's going to go perpendicular to the closest location that it can in the profile for our lead in and lead out for the rough cut. And then I'm going to click on leads over here under skim cut on the left hand side and check the box perpendicular to closest and hit compute. And so that's the closest location it found. It's going to go right to that location and cut around from there. If I want to change the start point, I could always right click under geometry right below the feature where it says EDM 2-axis inside in the cam tree here. I can right click on geometry and I can modify the start point right here. And then I can click anywhere on the profile here. Let's click at the 9 o'clock position right here on the left-hand side. Click OK. Compute the toolpath. Now it didn't change anything because I still have that perpendicular to closest location turned on. So if I want it manually set to this location at the 9 o'clock position on the spline, I have to go back into the feature. Right click on EDM 2-axis inside, hit edit, go to leads, and turn off that checkbox now, perpendicular to closest. That's a newer option in here now. It goes to the closest location that the software finds and starts from there, cuts from there. But we don't want to use that for this option here. We'll hit compute. And you can see, a little hard to see because it's a blue line for the toolpath, but it starts right here in the start hole and works its way to the 9 o'clock position here that I want it to start at. I'll wait a second to see if you guys have any questions regarding the CAD geometry that we made, the spline, and then this sort of wrench shape. And then if you guys had any questions with the 2-axis inside cut, please let me know. If not, we'll get into simulation and then posting the G-code here. I don't see any questions yet, so we're going to go right to simulation. I'm going to go to the top and hit start simulation here. So here's our shape. I don't see the upper guide and lower guide yet, and the reason for it is when we go to the top here, top left, where you see tool, or you might see workpiece stock, or you might see machine, you can drop down this option here, where there's tool, there's workpiece stock, and there's machine. I normally have it turned on to machine so that I can see the upper guide and lower guide, where it's starting at, and where it's going to cut around from there. And then I'm going to hit run. Now, if it goes too quickly on you, you have your simulation run speed up at the top here. You can change the slider bar over to the left or to the right. You also have the options here for to the left of machine now. You have time mode, length mode, and NC mode. NC mode will tell you how many lines of code, about 1,200 lines of code for this cut. If I drop it down again and go to length mode, it says the tool travel, about 57 inches. And then if I drop it down again, I go to time mode, and it says it will take 50 minutes and 10 seconds for the 10-inch per minute feed rate that I set here. I usually have it at time mode because you can see when I hit restart and hit run, in the NC mode, once I change it to NC mode, it can be a little choppy because it's simulating the lines of code. So it's simulating, okay, line move X and Y over to here, then the arc move. It's a little more of a choppy simulation, so I usually have it set to time mode anyway. I think it's a smoother simulation here. So there was our rough cut, and then it goes around for the skim cut. If I want to remove the shape in the middle, I can go down to the bottom here. I'm gonna have to move myself again. So down here at the bottom, there's this tab labeled measure. I can click on that, and then in the drop down, I can click remove chips. So the fourth one down, I normally select remove chips, and in parentheses, select chips. And I can click on the slug with the mouse wheel button here. I'm going to click on my mouse wheel, and it will remove that slug to fall out, and then I can see the part and make sure everything's cut to size. I can zoom in and see the arcs here, or the chamfers in the corners, and things like that. It's actually a radius now. I had to update the simulation there. Takes a second. But yeah, I can zoom in and zoom out in simulation. I can rotate around in simulation with my left mouse button, click and hold and move my mouse over, and I can pan over with my right click button and move my mouse over to pan over. Cool. Yeah, if you guys have any questions, please let me know. If not, we'll get into the 4-axis cut. We're going to do the same kind of shape, just with a taper angle all the way around. So I'm going to close out of the simulation. And we're going to make the profile down at the bottom of the stock. So if I rotate the part around or rotate the stock around, I can see the tool path. This is sort of like the location of the wire in green here at each point around the spline. I want to blank everything out. So what I'm going to do is I'm going to hit the eyeball icon to the left of Wire EDM job over here in the cam tree. I'm going to blank that out. And I'm going to make another profile of the spline here down 1 inch down to the bottom of my stock here. So I'm going to do that. First, I'm going to make a new layer so that I can place the geometry on a new layer here. So under layers, down at the bottom right here, you can see my layers page. You might have it hidden in a different tab over here. And if you don't see it, you can always right click at the top and show your layers page. But I'm going to right click in the layers page and go to add new layer. I'm going to name it taper. I'm going to go to the top in the different tabs. I'm going to go to my utilities tab. And the first operation is translate. So I'm going to click on translate. I'm going to go to a top view again. And I'm going to hold shift and click to chain select my spline shape. And I'm going to select my translate amount. X and Y are okay. I'm just going to drop it down in Z 1 inch. So I'm going to type in -1 for Z and hit tab to update the numbers there and see the preview there of the spline down 1 inch. And I'm going to make a copy of it. So there's a copies button down at the bottom of translate. I'm going to hit copies. I'm going to leave that at 1. And then I'm going to hit OK. I could have scaled it down at the same time, but it's okay. It's not a big deal. I can scale it down after the fact. Let's see. Okay, so this is a good point to make. The geometry that I made a copy of, it does not place it on a different layer. It keeps it on the original layer that the original geometry was on. So I still have to place the bottom geometry here on my taper layer. I can do that after the fact by making the taper angle active with the green check mark. I can go to the top and I can go to my select mode. I can chain select the bottom profile here. And then I'm going to right click anywhere in the CAD workspace here, just anywhere, and go to modify to current. And I'm going to modify it to the current layer. So now that taper geometry is on, or the geometry I just made is on the taper layer. And so when I blank out the CAD layer, that's the only one showing now. Let's say I want to scale it down to a certain size, but I don't remember what size it is originally. I'm going to find that out by right-clicking anywhere in the CAD workspace here. And there's this option halfway down, Entity Summary. So I'm going to click Entity Summary. It's going to tell me the minimum and maximum locations. So min and max are for the bounds. 9.8750 is right here. For the shape that I have showing, maximum of 14 1/8 is over here. And the difference is 14 1/4 is the shape of my spline in X and Y. and it's down 1 inch in Z. So I'm going to copy this number. I'm just going to highlight it and copy it and click OK. So right now it's 4 1/4. Let's say we want to make it, I don't know, let's say we want to make it 3.8, 3.800. I can do that by going to Utilities and going to Scale, the 4th option over. I'm going to highlight my spline, so I can window select it like this, or I can chain select it. And so for my scale factor here, our formula is what I want divided by what I have. So I want it to be 3.800 divided by what I have currently is 4.250. So that's a good formula to use in the scaling function. What I want the shape to be divided by what I have as my shape currently to scale it up or scale it down that amount. Once I hit tab, it's got a scale factor. The decimal is 894. 0.8941 to be exact, if you guys have that. And then you click OK. Then cancel out. If I show my CAD layer again, there's our tapering between the two there. So I've got the bottom taper. I've got the top taper that I want. And now I'm just going to go into 4-axis cutting. So you can go back into the original if you wanted to. I'm going to start from scratch. So I'm going to delete the Wire EDM job that I had so that we can go into a fresh new Wire EDM job for the 4-axis cut here. So I'm going to click on Wire EDM job in the CAM tree, hit delete on my keyboard, or I can right click on it and hit delete to delete that out. So we've got our geometry. Everything in CAD is good to go. We're going to go to the top and go to CAM and go to a new job. We're going to go to Wire EDM and we're going to go to Bannock 4-axis again, and then go to our stock wizard. Now again, if I had my workpiece, we could select it here, my 3D model, and view it in simulation, make sure it's cut to size. We don't have the 3D model, so we'll skip this page. And then we go to our stock page. And so again, for my shape, I'm going to go to wireframe. I'm going to select this hole first. I'm going to select the starting hole here as well. And then I'm going to hold shift and click on the outside profile of our shape to chain select everything on the outside for my stock and then hit calculate stock. So if you guys have been following along with the geometry, the wireframe that I made, your spline down at the bottom here of 3.800 should be right in line with your stock on the bottom here of 1 inch for your height. And then our last page is our machine setup, our G54 location, which is right here on this hole on the left-hand side. And so we'll scroll down in the machine setup and click OK. Now I made this example because I worked with a customer recently that had a starting point, a reference point right here. They had to fixture this stock so that this is our 0 location. We had to move out 12 inches and then do the profile cut around like this. If, for example, for whatever reason, maybe you import your file like this from your customer and you need your reference point right here, you can easily change the reference point by right-clicking on Machine Setup 1. Now this is in the CAM tree. This is on the CAM side of things. In the CAM tree, right-click on Machine Setup 1 and go to Edit. Highlight Origin in the CAM tree. Highlight the starting hole here and click on this point here. Now you can see the location of our coordinate system is x12, y0, z0. So in the G code, if I were to leave it like this would be X0, Y0 in the G code, and then it would be going in the negative amount if we're starting at the 9 o'clock position and going around. So this would be X0, Y0. This would be X negative 2, about X negative 2.1 maybe right here, and then going around from there, all in negative X and negative Y. And then once we get to here, it'll be positive X and positive Y coordinates in the G code. But again, I'm going to go back to my reference point right here. So I could highlight origin over here on the left-hand side in the CAM tree again, highlight this hole and click on the center point of the hole there. Or I could type in X0, Y0 right here if I know my exact coordinates that I need to move it to in terms of CAD coordinates. That's what these numbers are for. So throwing a couple concepts out at you guys. If you guys have any questions with those, please let me know. But our next step here is clicking OK down at the bottom. So if you're following along, you should have the Wire EDM job set up with your Fanuc 4-axis machine. If we drop this down, we have our Fanuc 4-axis EDM post-processor. We have our stock of 1 inch thick, and we have our machine set up here in the center of this hole, lining up with our CAD origin location. Awesome. So I'll go back to a top view. For now, I'm going to turn off the stock. So I'm just going to go to the stock here, and there is the blank button to the left of it. So I'll blank that out so we can see the top and bottom profile here. Next, I'm going to right-click on Machine Setup 1, and I'm going to go to 4-axis. So earlier we did the 2-axis inside. This time we're going to do 4-axis inside. Now you can see 3 different geometry options in the 4-axis cut. There was only one option in the 2-axis profile cutting. So now I'm going to select upper profile. I'm going to hide the layer that the taper layer is on. So I have to make the CAD layer active first. Then I can blank out the layer, the taper layer here, because I want to make sure I'm not selecting that bottom profile. So I'm just chain selecting the top profile here, and then scrolling down in my CAM tree over on the left-hand side and clicking OK. Then I can select my lower profile next, the second button here, and I'm going to turn on the taper layer, and I'm going to turn off the CAD layer. This is a great reason why I'm separating out geometry in different layers so I know that I'm selecting the right one here. And then I'm going to chain select the bottom profile and click OK down in the bottom left corner here in my CAM tree and click OK. Now, sync lines. We don't have to select sync lines for this one. I will show you this in the future of what this may be useful for, but we don't have to use it for this example. I'll show you in our next example after this, just to show you why we might need to use sync lines, but not for this one. We're just selecting the upper and lower profile for this and clicking Next. Next, we go to our upper guide, lower guide. Again, I'm going to turn off glue stops. You don't have to do this tab cut. I'm just going to select No Glue Stop and click Next. We're going to do a rough cut and a skim cut again, just like we did for the 2-axis profile cut. In all of these options, you'll see we're going to be doing the same exact thing as we did with our 2-axis profile cutting. So same kind of workflow. You don't have to learn a whole many new concepts in 4-axis, just the fact of the different geometry selection there, basically. Get to our next page, cutting conditions. Next page, tolerance level. Next page, machine comp. Next page, and just to let you know, I'm leaving all of these options as default options. Next page, I am changing something. with our lead in and lead out. I'm doing the same thing as our 2-axis cut. I'm going to select point and pick points. I'm turning on the CAD layer again so that I can select the start hole, the center point of the start hole here, and click OK. Should be at X12, Y0. Next page, cutting conditions. I'm going to set the same options as before, offset of 1,000. Power setting is 0, feed rate of 10 inches per minute. Now, if I'm always setting these numbers for a rough cut in Wire EDM, offset, feed rate, speed, tension of the wire for a rough cut, I can go down to the bottom and I can click Save Defaults here. And so when I hit Save, every time I do a rough cut, it will have these numbers populated by default. Offset of 1,000, feed rate of 10 inches per minute. Next page, machine comp, leaving that the same as what it is by default. Lead in, lead out, I'm going to change that to my select point, pick points, pick the starting hole location, the center point of the starting hole there. Next page, offset and feed rate, 1,000 for the offset and 10 inches per minute for the feed rate, so that I can see my simulation and see the cycle time in simulation for my based on my feed rate I set. Now that's our last page, so we'll hit compute. Now this is some pretty crazy toolpath. I don't think this is exactly what we want. Let's see what it looks like in the back plot. So I'm going to right click on 4-axis rough cut, the second to last option down at the bottom here in the CAM tree. I'm going to right click and I'm going to go to back plot, 5th option down. In this, I can see the wire here in yellow, and I can see it move around and see the exact location of where it's going to be at each location here. So with this back plot, if I zoom in and look at it well enough, let's see, how does it look from a top view? Yeah, it looks like it's on the wrong one. So if I can step through, so here in back plot at the top left, I can hit play to run through it. I can also step through it to see the location of each location there. I don't know, to me it doesn't look correct. But to make sure that it is, I can look at it in a top view, and I can make sure the start points are correct for both of the rough cut and the skim cut. And that's done in upper geometry and lower geometry. So yeah, just as I expected, you can see we're one tooth off. Look, if I highlight upper geometry, our start point is up here. Lower geometry, I'm starting the wire one tooth off of the upper geometry. So I want those to sync up. So I'm going to right click on upper geometry, and I'm going to modify start point, and I'm going to click on the 3 o'clock position exactly. So right here, halfway along the upper profile of this line here. Scroll down in the CAM tree and click OK. I'm going to right click on lower geometry, modify start point, and then I'm going to scroll down, and then I'm going to click right there at the exactly at the 3 o'clock position. Now notice if I click on it a second time, it'll reverse the direction. I don't want that because I want them to both go the correct direction there. And I want to make sure it's starting right at the 3 o'clock position for both of them, and click OK in the CAM tree. So then I can highlight each one, make sure they're both at the 3 o'clock position right there. I can right click on EDM 4-axis inside and hit Compute All Toolpath, the 3rd option down. That looks a lot better because now when I look at it on an angle, these green lines are going to be where the wire is going to sync up to from the upper to the lower profile here. And again, I can backplot it. Right click on 4-axis rough cut, hit backplot, and then I can run through it. That looks better there as it goes around. Then I'll close out of backplot. I can turn on my stock again by hitting the blank option or unblank to the left of the stock. We have blank and unblank to the left of each feature. And there's also a button next to it, this posting option. So this post yes, no option. So you could say with this icon, with the controller with the red X, this is our post no option. If I turn it off, this is our post yes option. That's how I would describe it. So let's say, for example, I did the rough cut and I need to do the skim cut still, but some issues at the machine. Maybe I only did the rough cut and now I need to output the program just for the skim cut. I can turn off the rough cut in simulation and in posting the G code with this posting option. So post no for the rough cut, post yes for the skim cut with this example. So that can be really useful in all of our programming, milling, turning, wire EDM. If there's some operations you've already cut, some you haven't in the CAM tree, you don't have to delete the operations and then bring them back if you need to. You can just turn them off temporarily with this posting option. All right, cool. Next, we'll look at our simulation. I've got the rough cut and skim cut turned on, by the way. We'll just simulate and post the G code for the 4-axis cut here. So I'm going to go to the top, click Start Simulation. Going to rotate it around, zoom in a little bit, hit Run. Something that I find interesting is that the 2-axis cut was 50. It took 50 minutes, I believe, and this one is taking only about 8 minutes. So I'm not sure what the 2-axis. I may not have typed in the same feed rate as I typed in here, but it's interesting that it's a little bit of a different cycle time there. So yeah, I'm just going to hit Restart and hit Run. If the toolpath is in the way for you, you can click on toolpath up at the top here, and it will turn off the visual of the toolpath there. Again, down at the bottom right, we've got this measure tab. Under the drop down, I click on remove chips, select chips. I click on the slug here with the scroll wheel of my mouse, and it drops the slug out of it, and then I can zoom in. Again, it takes a few seconds to optimize the graphics there for simulation, but that's once it updates, you can see the cut there in 4-axis. I can look at it from a top view by clicking on this plane over here for top, so I can look down on it and make sure I've got that taper angle there. Looking good. So then I'm going to close out of simulation. The only other topic that I could think of for wire today is sync lines. But if you guys have any questions, please let me know in the comments section. I can answer anything else that you may have questions on for today. So the sync lines over here that you can see in the CAM tree, you can see it's not selected with this red plus. If there's any kind of red plus next to something, it means that there's nothing selected for it. So I'm going to blank everything out. I'm going to blank out the whole wire EDM job in the CAM tree, and I'm going to make some sync lines to show you what they are. I'm going to go to create 2D, and I'm going to go to line. And from the 3 o'clock position here, I'm just going to make a line from the top profile to the lower profile from point to point here. And that's a sync line. So that is a line that I can select in the CAM tree over here in 4-axis. So I right click on sync lines. I go to reselect. I select that as a sync line. So I'm telling BobCAD that is a location, a taper angle that BobCAD needs to sync the wire up to in my 4-axis profile. And then as it goes around, I can go back to create 2D in the CAD side of things and go to line. I can select going around the tooth of the gear here. I can select this point and then select the corresponding position on my lower profile there. And then I can use that as a sync line. So again, this isn't necessary in my 4-axis cut for this example because these are two shapes that are the same shape, scaled down a little bit differently. But if I had two shapes that are totally different and I need to tell the software, okay, I need you to sync the line, I need you to sync the wire from this position on the upper profile to this position at this kind of angle on the lower profile, I can select that as a sync line. Let's just select that one here. Curious on how it'll output the toolpath here. Then I'll compute the toolpath, and let's see how that looks. So you can see it goes a little wonky in that location because now it's going to start here, and then it's going to try to angle the wire to sync it up to that line that I made. Hence the term sync line. So sync line, and also, so I'm going to remove that sync line there and recompute. That should look better now. And the only other thing I could think of also would be posting in X, Y, or in UV coordinates. So I'm going to go to the top and I'm going to click on post. That's the button right next to simulation. Down at the bottom right, we have our G code. And by default, it looks like the Fanuc 4-axis machine and post processor are outputting in I, J, and K values here. So you've got X, Y, I, and J, and X, Y, I, and J on this line of code. So some machines take I and J values for your 4-axis. Some machines take X, Y, and then UV instead of I and J. If you need it to output in X, Y, UV, I believe the easiest way would be right-clicking on Wire EDM job, go to current settings, and we change it from 4-axis entities up at the top right here, 4-axis output, to X, Y, UV. Click OK, and post the G code again. There's our X, Y, and UV coordinates. So depending on what your machine takes for your 4-axis output, that's what you can output right there. Again, that's in the CAM tree. Right-click on Wire EDM job, go to current settings, and change it from 4-axis for I and J, and XYUV for XYUV. Over on the left-hand side, you can also change the file extension if you needed to change it to anything other than .nc. Under EDM posting on the left-hand side, you can change NC file extension from .nc to .cnc to .tap or whatever file extension you need for your machine there. So then, when you post the G code, you can right-click anywhere in the posting window and go to Save As. And then you can see the file extension it defaults to .cnc that I typed in there. And then you can save it onto a flash drive and send it over to the controller from there. That's about it with the 4-axis that I have to cover today. So again, just want to reiterate the machine setup and how that looks. So when I output the G code, you can see my first position is a G01 move to X 3.9. So that is starting over here in the start hole. And so that is, well, actually, sorry, should have an X12. Here we are. So G00, X12, Y1 is the first X position, which is the start hole. And then it moves over to X 13.9. So you can see that in the G code because it's referenced as X0, Y0 in this hole over here. If you need this to be X0, Y0, again, we could do that after the fact by right-clicking on Machine Setup 1 and going to Edit, highlight Origin, and then from my top view, I'm going to select my center point of the start hole here, and then click OK. Now you'll see the G code will update 12 inches over, and the reason for that is because I've shifted my work offset, but I haven't updated my toolpath for my new offset at the center here. All I have to do is right-click on EDM 4-axis inside, right-click on the feature in the CAM tree, go to Update All Geometry, second option down, and then right-click on EDM 4-axis inside, right-click on the feature again, and go to Compute All Toolpath. It'll shift the G code back over. Here's a good point to make, though. Let's look at this. Lead in and lead out here. This is my lead in and lead out, X12Y0, in reference to the work offset. So I have to go back to pick points and pick that point again. Click OK, and now it's X0, Y0. So these are not referencing the CAD coordinates. They are referencing your current work offset. So that's a good point to make, is so that I don't move the wire over 12 inches and cut right through the wrench shape that I have here. So we'll go to leads for the skim cut. I'm going to go to pick points and reselect my geometry. You could just type in X0, Y0 here if you wanted to. But I'm just going to reselect my points and make sure I have the right reference point there and hit compute. Now that looks a lot better. So again, I'm saving my BobCAD file as webinar.bbcd. And then I go to the top and I go to post. I look at the G code. I see that I'm starting at X0, Y0 now, and then moving over to X 1.9 inches over in X to the 3 o'clock position here. So that all looks good. And so if this is the G code I want to use, I can right-click on it, save it, and save as a G code file. So those are our two separate files in BobCAD. Our BobCAD file, which will save the geometry and everything here that I've saved in my CAM tree, and my G code file, normally saved as .nc, to send over to the machine once I save it on a flash drive. And if you guys have any questions on what we've covered today, please let me know in the comment section. I want to thank everyone for viewing the live event today, going over 2-axis and 4-axis wire EDM. We do a live event like this every other Wednesday. So in May, we'll have a couple of them, I think. We'll have one on the 14th of May, and then our next one is going to be May 28th after that. But yeah, next one is May 14th, 1 o'clock p.m. Eastern Time, and we're going to be doing it live just like this one here. And we send you guys an email to make sure that we have the right topic in mind for you guys. So we send out a quick survey asking you what's the next webinar you guys would like to see, so that we make sure these are tailored to exactly what you're looking for. But yeah, our next live event is May 14th, 1 o'clock p.m. Eastern Time. Hope to see you in the next one. And thank you guys for viewing the live event live today, this webinar live. And hope to see you in the next one. Thanks again. See ya.